Hello everyone, welcome to our channel Off Campus. In this video we are going to discuss about some multiple choice questions in PN junction. Okay, let's start the video. First question, what is that? When the PN junction is forward biased, the sequence of events that take place are, this is the very important question. When the PN junction is forward biased, what is the sequence of events that take place are? Four different options are given. In that, what is the correct order or correct sequence of events? Is nothing but injection, diffusion and recombination. Injection, diffusion and recombination. Option B is the right option for this problem. Next, move on to the second question. The depletion region of PN junction is 1, that is depleted of four options are given. Atoms, mobile charges, immobile charges, velocity of the carriers. So, option B, mobile charges is the right option for this problem. Next, question number 3, the depletion region within a PN junction is reduced when the depletion region within a PN junction is reduced when it is zero bias or forward bias or reverse bias or all of this. When it is forward bias only, the depletion width of the depletion region is reduced. So, option B, forward bias is the right option for this problem question. So, question number 4, a silicon PN junction in forward conduction has a voltage drop closer to, it is 0.7 volt. What is the voltage drop for the silicon PN junction in forward? So, forward bias, it is nothing but option B, 0.7 volt. Then, question number 5, for a reverse biased PN junction, the current through the junction increases abruptly as. In a reverse bias PN junction, the current through the junction increases abruptly at. Four different options are given. What is the correct one? Breakdown voltage. Option A, when the breakdown voltage, it increases abruptly at the breakdown voltage. For a reverse bias PN junction, the current through the junction increases abruptly at breakdown voltage. Okay. Next, sixth one. The reverse saturation current of a PN junction varies with temperature T as answer T. Current is varies temperature as T means when the current is reverse saturation current is increases when the temperature also increases. It is varies directly related to reverse saturation current is directly proportional to the temperature T. So, option A, T is the right option. Then 7, the transition capacitance of a reverse biased PN junction having uniform doping on both sides varies with junction voltage VB as. So, what is the transition capacitance of a reverse bias PN junction having uniform doping on both sides varies the, what is the junction voltage VB. So, what is the it is proportion or something ratio, not ratio, how it will be. Okay, before going to see the options, we need to know the PN junction diode can exhibits two type of capacitance only at higher frequencies. At higher frequencies, PN junction can exhibit two type of capacitance. What is that? One is diffusion capacitance, other one is transition capacitance, or transition can be depletion. Other name of transition capacitance is depletion capacitance. So, diffusion capacitance and transition capacitance. What is diffusion capacitance? Dominates under forward bias. Okay, whereas transition capacitance, in that question, capacitance of it dominates under reverse bias. So, what is the relation? When a transition capacitance of a reverse bias PN junction, VB, it is in the power. So, power minus 1 by 2. It is like power VB, junction voltage VB in the power of minus 1 by 2. Okay, answer C is the right option. Next, question number 8. The leakage current of a PN junction is caused by four different options are given: heat energy, chemical energy, barrier potential, majority carriers. So, the leakage current of a PN junction is caused by option A, heat energy. It is caused by heat energy. Then next one, the junction capacitance of a linearly graded junction varies with the applied reverse bias VRS. So, previously we have seen one capacitance, transition capacitance. Other name there are many names, few different names for transition capacitance. It dominates under reverse bias only. So, transition capacitor, other name, what is that? It is another name, one of few of the another names are depletion capacitance or junction capacitance. Transition capacitance can be otherwise called as depletion capacitance or junction capacitance. So, it is having uniform doping on variously. So, when it is not anything on, see, let us see that question. Capacitance of linearly graded. So, two different types. One is strip graded or abrupt graded. This is very important. So, I am explaining again and again. See, junction capacitance or transition capacitance or depletion capacitance, which dominates under only reverse bias. It dominates under only reverse bias. In that junction capacitance or transition capacitance, there is two graded. One is linearly graded junction, another one is abrupt graded junction. So how can we relate the junction capacitance with the applied reverse bias voltage or barrier voltage? So VR or VB is same only. It is given as linearly graded. Another one, what I told, linearly graded or step graded. Step graded, another name of step graded is nothing but abrupt. Okay, when it is given abrupt or step are same. So, linearly graded means it is varies in the power of minus 1 by 3, VR power minus 1 by 3. When it is not mentioned anything, we can here see in that question they are not mentioning anything, okay, whether it is linearly graded or step graded. Another name of step graded is known as abruptly. They have given keyword as abruptly also. So, here nothing is mentioned. If nothing is mentioned, we can take it as abrupt or step graded. When it is step graded or abrupt, VB junction voltage in the VB power minus 1 by 2. When it is linearly graded, it is VR power minus 1 by 3. Okay, option C, VR power minus 1 by 3 is the right option for this problem. Then question number 10, the diffusion capacitance of a forward biased P plus N junction, that is P plus in the superscript in the power of the P. So, P plus N junction diode with a steady state current I depends on 4 different options are given: width of the depleted region, mean lifetime of the holes, mean lifetime of the electrons, or option D, junction area. A P plus N junction diode is a diode with very heavily doped P region. What is given? The diffusion capacitance. I have already told there is one junction capacitance and diffusion capacitance in PN junction. So, diffusion capacitance dominates under forward bias, whereas junction capacitance or what is that another name, depletion or transition capacitance dominates under reverse bias. So, let it be. What is the question here? The diffusion capacitance of a forward biased, okay, P plus N junction diode with a steady state current I depends on the mean lifetime of the electrons. Option C, mean lifetime of the electrons is the right option for this problem. So, we have seen around 10 MCQs in PN junction diode. Thanks for watching. If you are, please like, share and subscribe. Thank you.